This lesson covers the types of IPv6 address. With IPv4, there really wasn't any kind of special IPv4 address. There were classes. There was the class ABC. I could think about my IP address could have come from an internet authority, so it was publicly routable. It could have been from a set of private IP addresses, the 10.172.16, 192.168. It could have been an automatically assigned 169.254, but it was still just a single IP address. IPv6 actually changes this. IPv6 defines a scope for IP addresses. There is a global address. This is the same as a public IPv4 address. There is a unique local address. This is like an internal IPv4 address, i.e. I pick that range, but it's not routable on the public internet. Then there's linked local address. This is like that automatically assigned IP address, the 169.254. It's where it works out its own IP address, so it can talk to machines on the local network. Now, machines may have any number of these. IPv6 routers are configured to route packets of a certain type. It will not forward a packet that has the wrong scope type. When I query DNS, multiple IP addresses are returned, and clients will use the address with the most appropriate scope type. So the client knows where they are, they understand the types of address they have, and then based on that return, they'll try and use the one that's kind of closest to them. Now let's look at those different types in more detail. There is the global address. This is a unicast address, a one-to-one. This is globally routable. So this is like a public IP address. Now, because there are so many possible IP addresses with IPv6, I can, as an organization, get a huge set of addresses. What actually happens is the first 3 bits of this IP address are 001. The next 45 bits are the global routing prefix. So this is assigned to my organization by that internet governing body. The next 16 bits are then reserved for me to break up that space into 16 bits. So obviously that's half of the old address space we had in total for IPv4. Then the last 64 are reserved for the interface ID, i.e. the host address. Now that does seem like a lot, and I'm going to explain why that is so big later on. But for right now, the first 3 bits are always 001, then the next 45 bits are assigned. I can then split up the remaining part of kind of the network address in the following 16 bits. It is routable, but I don't have to enable that. I can block certain machines from talking. I can only allow certain types of traffic. So I would still have a firewall between my internal network and the internet. I just don't have to do network address translation anymore. So that's one approach. I can go to the governing body. I can say, I want an address space, please. They will give me my global routing prefix, and I would use that. I would actually probably get that from my internet provider. They would work with me so they can actually then go ahead and route that space. The next approach, remember, I can have multiple ones of these. I can have a link local. Now the link local, this is like the 169.254, the automatic. These are used by nodes to communicate that on the same subnet. I can do neighbor discovery processes, and these are just automatically configured. If I was to look at my machine, and if I run an ipconfig/all, you can see I have various IP addresses, and I have a link local IPv6. So that was that automatically assigned IP address, FE80, which is what it will always start with because of those first bits. The first bits, as I showed in the diagram, it's always 1111111010. So that's the first 10 bits. So that's going to force, if I go to my calculator, go to binary 1111111010 and then 00, because it's a chunk, remember, of 16 bits, that gives me FE8. So they always start with the FE80, and that is my link local address. So it automatically assigned itself this address. It would try and talk to other people on the network, make sure it doesn't clash. So notice it has 2 colons. They're all zeros. So it was FE80, 0:0:0:0, and then this part of the address. Because with a link local, all of the following 54 bits are zeros. So it's always going to be FE80 colon 0 colon 0 colon 0 colon then the interface ID part. So you'll always see FE80 colon colon and then 4 blocks. So I always have that IP address as well. Then I can have a unique local address. This replaced an old site local address that had some problems. And so with this address, this is really the same as that 10.172.16.192.168. Here, the first 7 bits are always 1111.110. The 8th bit is also always 1. So that's going to give me FD00. And then I have a global ID. I pick this. I create this global ID for my organization. In the same way with IPv4, I would pick, well, I'm going to use 10.0, or I'm going to pick 172.16, or I'm going to use 192.168, whatever. I pick that global ID. I would then use something to push out those IP addresses to my clients. Maybe I statically configure it. That's very unusual. I'm pretty much always going to use DHCP in some capacity here. Once again, the next 16 bits of the network address are used for subnetting. And once again, the last 64 are always the interface ID. So no matter which one of these I have, the last 64 are always the interface ID. The first 64 are always the network address. There is an easier way to work out that global ID, which I'll talk about in a second when I use the unique local. There are special addresses. Just like with IPv4, there's these IPv6 equivalents, the unspecified, loopback, if it's auto-configured. There is no broadcast in IPv6, we use multicast. And then multicast is something FF00. So those same types of special address. Which one of that global address, link local or unique local you use is really up to you. You're always going to have a link local. You might want to do unique local and global address. Probably not. So if you can, through your provider of internet service, your partners, you could get a global address portion of the namespace and just use that on your machines. If not, and you still want to use some kind of NAT, then you could use a unique local range. So a bit more detail on that unique local range. There's actually a good website, and this simple DNS, it will actually go and generate for me a unique GUID, that globally unique part. Now, is it guaranteed to be unique? No, but there's a pretty good chance it will be unique. Why do you even care if this is unique? Think about the IPv4. I had that 10 dot, let's say I pick that. It doesn't matter that another company uses that because it's non-routable on the internet. Now imagine 2 companies merge and both companies using 10 dot. That's actually a pretty big problem. They have to go through very painful re-IPing. So with this approach, when I use that unique local, there's that entire part of the address, those 40 bits, the global ID, that are very unlikely to be the same for 2 different companies. If I randomly select 40 bits, there's pretty much 0 chance they will be the same. So even if there is another company in the world that has the same global ID that you picked for your unique local, unless you have the misfortune of choosing to merge with them, it's really not a problem. But this website, if you go here, it will help generate you an automatic IP range. So here you see I went to the site and it automatically created a global ID for me. And it's showing me how I'd actually use that in my environment. If I refresh, it gives me a new one. So it is just randomly generating that global ID part for me. And I just then use that in my environment. So in this case, I would use that as part of my configuration. How I deploy this will probably be DHCP. So if I look at DHCP, there is a v6. I create a scope based on the information that site gives me, and that would then assign it to the machines in my environment. Now, clients will attempt to auto-configure. They will use neighbor advertisement, and then routers can actually send solicitation messages that will specify how clients should actually get their configuration. Are they managed, or should they use some other configuration protocol? So using those configurations, I can tell my clients, hey, you should be using DHCP v6. You should be using it for certain configurations and not others. Maybe use it for the address, but not the configuration. Or use it for the address, but not other settings. That's not very common. So you're probably going to use DHCP You're going to let it assign the IP addresses. Yes, you can manually configure it, but that really is pretty painful. So most of the time, you're going to want to use DHCP to assign your global addresses and your unique local addresses. Remember, link local, they are automatically configured.